when the battery remains connected to the capacitor. When the battery is connected to the capacitor. Now we are going to analyze let me consider two plates, and you have the battery connection. These are all plus, these are all minus. You know the distance between these two parallel plates is d. So d is the distance between parallel plates of capacitor, and you got the electric field starting from plus to minus like this inside the parallel plate capacitors, that is represented as E vector. So electric field vector. Okay. So if it is in absence of dielectric, means it is E naught, is it not? That we know already. So without dielectric. Okay. We know Q is equal to epsilon R into Q naught. What is epsilon naught? We already know, relative permittivity, is it not? Of certain medium. And then Q naught is the charge without dielectric. Q is charge with dielectric. Okay. Now we have connected to the plus of a battery and minus is connected to this plate. Okay. Now due to the increased charge, the capacitance is also increasing, because C is equal to Q by V naught, and that is equal to V naught. Now Q is equal to, we can apply this equation, so this becomes epsilon R into Q naught divided by V naught. So Q naught by V naught is nothing but C naught, is it not? So we can make this as epsilon R into C naught. Okay. Now this C naught is equal to, according to the equation, A into epsilon naught divided by D, right? and for capacitance with the dielectric, A epsilon divided by D. Okay, A epsilon into D, where epsilon is equal to permittivity of certain medium. Certain medium. So this epsilon is also given as epsilon naught into epsilon r. Okay. Now we already discussed about the energy that is given by U naught, that is without battery. Without dielectric. Potential energy without dielectric is given by 1 by 2 into C naught into V naught squared. Is it not? So this is a very important equation. U naught is equal to C naught divided by half into C naught into V naught squared. And we can replace this also by U naught is equal to, and CV, instead of CV we are putting here Q. So 1 by 2 C naught V naught squared is nothing but Q naught squared divided by C naught. Okay. So this is without the dielectric. Now we are inserting dielectric. These are all the cases without dielectric. Now we are inserting a dielectric. After inserting dielectric, the capacitance is increased because U is equal to 1 by 2 C into V naught square. So that is equal to, this V naught is 1 by 2 into C into V naught square, and we can introduce 1 by 2, instead of C we put C naught into epsilon r into C. Okay, C naught, and we have got already, because we know C is equal to C naught into epsilon r. So I am replacing this C by C naught into epsilon r, and we have got already this V naught squared. Okay. So it means now we can replace this 1 by 2 C V naught squared, that is 1 by 2. Okay, and then C naught V naught squared is equal to U naught. 1 by 2 C naught V naught squared is equal to U naught. So you can replace this. Therefore U is equal to, what is that? U naught into epsilon r. Okay, right? So in that case, when epsilon r is greater than 1, it increases, U increases. So U is greater than U naught. Are you able to follow? But when you compare with the connection without battery, it is almost U is equal to U naught by epsilon r, where it decreases, and in this case it increases. So you have to point out this difference. So the energy density is given by, take down, energy density, it is given by U. So U is equal to 1 by 2 into electric field square, okay, where this 1 by 2 into electric field into epsilon, okay. So there is a very important equation where epsilon is equal to epsilon naught into epsilon r. It means epsilon is equal to permittivity, take down, permittivity of certain medium, whereas epsilon naught means permittivity through free space, that is vacuum, correct, and epsilon r means relative permittivity of the medium. In fact, when epsilon r, that is dielectric constant, is greater than 1, it becomes insulative material, okay, that is dielectric, and that's why we call this epsilon r as dielectric constant also. Do you understand this? So what is this epsilon? Permittivity through certain medium. Here through certain medium means it is dielectric. Are you able to follow? Here we are introducing dielectric, that is insulator, okay. Is it clear? So now we can summarize all together, okay. Take down effect of dielectric in capacitors. Now here we have the dielectric inserted here without dielectric, okay, we have like this, right, and what are the various parameters? Let us write down here various parameters. For example, Q, and then voltage, potential difference, electric field, capacitance, potential, the energy stored in the capacitor. So with the dielectric means, that is now when the battery is connected, and that is also discussed here, okay. Now it becomes what? Constant, okay, when the let us see, that is dielectric is inserted here, okay, dielectric inserted, and this is not inserted, and it means when the battery is disconnected, you can write like this also, okay. So when the battery is disconnected, Q is constant and the voltage is what? Decreasing. So dielectric is inserted when the battery is disconnected. Okay, when the battery is disconnected, Q, are you able to follow, is constant. Okay, Q is constant. We'll put here Q is constant, and then voltage decreases, electric field decreases, capacitance increases, right? What about energy? Decreases. So except capacitance, all are decreasing. Are you able to follow this? Okay, except all are decreasing. Is that clear? Except capacitance, all are decreasing. That is Q is constant, of course, and V is decreasing, E is decreasing, U is also decreasing. This is the case when dielectric is inserted. Okay, and when dielectric is disconnected, and when dielectric is, when the battery, so here let me not talk about this without, and here let me say dielectric, these are all with the dielectric only. Here we will put when battery is connected. So instead of without a DE, you can put battery is connected. This is battery is disconnected. So these are the two parts, and all are understood with the dielectric only. Now what about Q? Q, when it is connected to the battery, it increases, correct? And what about V? V becomes constant, right? E also constant, and C increases, okay, and U here increases, in this case decreases. So you had to summarize all these things. Okay, so effect of dielectric in capacitor, and we are just talking about the influence of this dielectric, and that is always represented by, that is Q, V, E, C, U. Can you write down the equation for all? For example, in this case Q is constant, whereas here V is decreasing, means how to write down? V is equal to V naught divided by epsilon R. Okay, so what is the equation? V is equal to V naught by epsilon R. This is the equation. And what about this? This is also E is equal to E naught divided by epsilon R. But in this case, C is equal to, what is that? C naught into epsilon R. In this case, U is equal to how much? U naught divided by epsilon R. So here, tell me, battery is connected, Q is, how it is related? It is increasing, means Q naught into epsilon R, correct? And here, that is C is equal to C naught into epsilon R. And here U is equal to U naught into epsilon R. So with the connection, these are the results. Increases, is it not? Okay, right? And what is epsilon R? Relative permittivity of the dielectric medium. Okay, so this is the total summary. right?